All right, welcome. Today we're going to talk about something that's literally holding our entire world together, but you probably never even think about it. It's the invisible architecture, the universal language of measurement. So let me ask you this. Could we even have our modern world if we couldn't agree on what a kilogram is? I mean, just picture it. You're trying to launch a satellite, or hey, even just bake a cake from a recipe you found online. If your kilogram is different from the next person's, well, it's just total chaos, right? It'd be a world of constant mistakes, and that's exactly the problem we had to solve. Believe it or not, for most of human history, that chaos, that was just normal. Before we got our act together with a single global system, measurement was a total mess. It was all local.
No, really, think about it. You might have one town where a foot is literally the length of the mayor's foot. A stone's throw away, a stone of weight is totally different. So how are you supposed to do large-scale trade, or science, or engineering? You can't. It was pretty much impossible because we were all speaking different languages when it came to describing the physical world.
But then we came up with this brilliant, elegant solution, a system that was designed from the ground up to be rational, consistent, and, this is the key part, universal. And we call it the International System of Units.
You might know it as SI for short, from the French Système International. And really, it's the hero of our story today. It's the modern version of the metric system, and what it does is give us one single, coherent set of definitions. It lets scientists, engineers, and, all of us, talk to each other about measurements with absolute clarity.
And here's what's so beautiful about it. This whole system, as powerful and all-encompassing as it is actually built on a foundation that's shockingly simple.
Just 7. That's it. 7 base units. And from those 7, almost every single thing we can possibly measure. I'm talking the speed of your car, the heat of a distant star. All of it can be described just by combining these 7 fundamental ideas. They are literally the building blocks of how we describe physical reality.
First up, you've got length, and its unit is the meter. This is what defines space.
Next, there's mass. We measure that in the kilogram. This is all about the amount of stuff in an object, no matter where it is. Then we have time, measured in the good old second. It's the universal tick-tock that we all share.
Number 4 is electric current, measured in the ampere. This is the one that basically powers our entire modern life.
Then you've got temperature. And for science, we use Kelvin. It's the absolute scale for thermal energy. Next is the amount of substance. This one's a bit more for the chemists out there. It's the mole, and it's how we count atoms and molecules. And finally, number 7, luminous intensity, measured in the candela. It's all about how we define brightness. So there you have it. Length, mass, time, current, temperature, amount of substance, and luminous intensity. The magnificent 7, right? And from just these 7 fundamental concepts, we can literally build and describe, well, everything else. Okay, so how does that actually work? I mean, how do we get from just 7 simple ideas to, all the complexity of the world? The answer is simple. We just combine them. We call these derived quantities. And they're not some totally new concept. They're literally just combinations of our base units. Let's take something simple, like speed or velocity. What is it? It's just a distance, so that's length in meters, divided by an amount of time in seconds. That's it. Meters per second. Simple. And what's so cool is how this system just scales up so beautifully. So what's area? It's just length times length. What's volume? It's length times length times length. Density? Well, that's just our mass unit divided by our volume unit. See? Every new idea is built logically on top of the others. It's so elegant, and it's basically infinitely expandable. Now, this isn't just some abstract theory that only matters in a physics lab. This system is like the invisible operating system running in the background of your daily life. Think about your phone's GPS. The only reason it works is because the satellites flying way up there and the little receiver in your phone have an exact, shared understanding of what a meter is and what a second is. Global trade? It works because a kilogram of steel in Japan is the exact same as a kilogram in Germany.
Medical tests rely on perfectly precise measurements of things in your body. And don't even get me started on precision engineering. It just wouldn't exist without this system.
So this shared language does way more than just help us build stuff. It's like this quote says, it gives us the vocabulary, the actual words to describe the universe itself. And we can do it with, frankly, breathtaking accuracy.
And if you want proof, look no further than this number right here. That's the speed of light in a vacuum. It's one of the fundamental constants of our universe. And how do we define it? With perfect, unwavering precision, using just two of our base units, the meter and the second. This isn't just a system we made up, it's like we've tapped into the language of reality itself.
So our entire modern scientific world is built on this foundation of just 7 units, which it makes you wonder, right? As we learn more and more, as our knowledge keeps expanding, are we ever going to stumble upon something so fundamentally new that we need an 8th base unit? And if we do, what kind of new worlds will that 8th unit unlock for us to discover? Something to think about. Thanks for tuning in.